We're looking at solving inequalities by adding and subtracting. Super straightforward today. A reminder that with an inequality, that means that things are not equal on both sides, necessarily. We have four inequality symbols. We have these, which hopefully we remember. We see that this one means greater than. We see that this here is less than. We have these two symbols, which are often paired together. We have that this is greater than or equal to. And that this here is less than or equal to. Alright, so four inequality symbols. Now, when we solve inequalities, we're going to write the answer in what's called set builder notation. We're going to use set builder notation. So our answer is going to look something like, let's say, this was our final answer. Set builder notation. So it's going to read like this. The set of x's such that is that vertical line, such that x is greater than 7. So this, for our set builder here, we say the set of all x's such that x is greater than 7. That's a very formal way of writing our solutions to inequalities. And please, please, please get in the habit now of writing your solutions in set builder notation. So solve these inequalities, and we'll graph them on a number line. So this is just like solving an equation. So if we have d minus 14 is less than or equal to negative 19, well, we need to get d by itself, so I'm going to add 14 to both sides and we have d greater than negative 19 plus 14 is 5. So in set builder, I'm going to say that we have the set of all d such that d is greater than or equal to negative 5. Now when it comes to graphing this on a number line, I'm going to take a number line. I'm always going to provide a frame of reference of where 0 is. Always where 0 is. I'm going to put negative 5. Since this is what we would call inclusive, that means it's this or equal to. That means we put a solid dot here on negative 5. And then d is greater than negative 5. So we're going to shade all the values that are greater than negative 5 and go this way. Make our arrow nice and bold. We can scribble it, do something so that we can indicate that our solutions are all including negative 5 and greater than. Alright, let's look here. We have 18 is greater than p plus 8. I'm going to start and subtract 8 on both sides. So then we have 10 is greater than p. Now for set builder notation, we're always going to put the variable first. So we know that this is also p is less than 10. So our solution in set builder is the set p such that p is less than 10. Now when it comes to graph, I'm going to make a number line. Again, I'm always going to provide 0 as a frame of reference. And now I have 10. Now, p is just less than 10, but p cannot itself be 10. But it can get super, super, super close to 10 as you talk about limits in pre-calculus and calculus. But luckily we're not there yet. But for now we're just going to put an open circle on 10. An open circle on 10 meaning that it does not include 10. And then p is less than 10, so we are going to shade those values that are less than 10, which would be going this way on the number line. Alright, and finally let's look here at 5h is less than 12 plus 4h. So this time I'm going to subtract the variable term. I'm going to subtract 4h from both sides and see that I'm left with h is less than or equal to 12. So in set builder, it's the set of h such that 8 is less than or equal to 12. All right, and then on my number line, I always provide reference of where 0 is. And we take 12. Since we're less than or equal to 12, I'm going to put a solid closed circle dot on 12. And H is follow the direction of that less than sign and shade to the negative direction of 12. If and only if and when your variable is here first in front of that value, then you can kind of shade in the direction that that less than or equal to sign points. You know? So here we have our h, our variable here. We go less than, we can shade in that direction that it points. Let's look at some practice. Practice is going to be on page 708, looking at numbers 12 through 33, multiples of 3. So let's look here at 12. We have m minus 4 is less than 3. So I'm going to start by adding 4 on both sides. And I see that m is less than 7. So in a solution set, we would write the set of m such that m is less than 7. And then when I create a number line, I always like to use the lines on my paper as a base for a number line. Then I have a lot of room for that. I always provide where 0 is. I put 7. Less than means we don't include 7, so it has an open dot. You see that's open. And then m is less than 7, so we shade for those values less than 7. If you want to use colors for your shading, great. If you want to just make sure that your arrow is nice and bold so that I can distinguish which way is shaded and which way is not, it's up to you. But hopefully this won't be too bad, so hopefully these practice problems go smoothly.